Hey, welcome back. So our next problem in our two-pointer series asks us to consider a list of vertical lines of height n, where two vertical lines a distance d apart would be able to contain some water. For example, if we had two vertical lines of height 7 and 8, and they were 5 units apart, then they would contain 35 units of water, since the length of the container would be 5, and the height would be the minimum height of the two lines, or 7. Our task now is, for an array of vertical lines, we need to find the maximum amount of rainwater that we could contain. In order to solve this problem, we need to maximize the possible width of the container by placing a pointer on either end of the list. Then, in order to check all possible areas, we should move either pointer. Well, which pointer do we choose? Logically, the pointer to the number that is smaller must therefore be the pointer we should move, because we want to be greedy and choose the line with the biggest height, all else equal. At every possible choice, we want to make the locally optimal choice. We will continue to move pointers and record areas until the left pointer and the right pointer meet. Then the maximum area we found will be our answer. Let's test this idea with an example. So what we'll do is we'll place the pointers on either end of the list. 1 is the smaller number, so we move the left pointer up by 1. Then 3 is the smaller number, so we move the right pointer down by 1. We will continue in this way until the pointers meet. At last, we see that in our list of areas, 49 is the biggest area that we were able to find. Here's an even simpler example. Our only area is 1, and thus we will return that area. That's all that we can check. That will be our answer. Let's code the solution. We will first initialize pointers left and right on either end of the list. We also initialize an array list called areas. Then, while the left pointer is less than the right pointer, we will first append the area of the rainwater container, found by taking the distance between the left and the right pointers, times the minimum height between the two vertical lines pointed to, into our areas list. Then we will move the left pointer if the left height is smaller than the right height. Otherwise, we will move the right pointer. Once we are out of the while loop, we then return the maximum value of the areas list as our answer. The time complexity of this algorithm is O of n, because our pointers will point to every item in an input list of size n. Furthermore, the space complexity is also O of n, because we store a list of areas that is of size n. And I should mention as well that many solutions to this problem will use a constant space complexity. I chose a linear space complexity because I found that we could optimize the speed of the algorithm by only calling a max search once, instead of at each iteration of the loop, as is done in most solutions. You should be aware of the trade-off and consider what makes sense for each interview situation. At any rate, the problem is now solved. By now, the two-pointer method should be feeling pretty doable. Let me know what you think of my change and if you would do this in an interview situation. I'd love to hear your feedback. Thanks a lot and take care.